Thank you for coming. Presentation is about perceptive approach to droning. I had a bit of a technology problem this morning. My computer is older, and I guess the new HDMI equipment has a new signal that they use, and my computer cannot run that signal. So one of the tech guys was very kind to lend me his MacBook and throw on the presentation, but I will be using the Tonal Energy app to kind of show a few exercises when it comes to droning and perception and things like that. But thanks for coming. This is me. I teach at the University of Idaho. I'm the horn professor and concert band director there. And if you have any more questions, I did post this presentation on my website, which I'm happy to share with you guys if you have any questions. But today I want to talk about creating expectation. How it is we develop pitch not only as youngsters, but if we come to the instrument very late, which is what I did. I came very late, and my perception of pitch was very different than not only as a high schooler, but even late into college. It took me a lot longer to adjust and learn how to perceive pitch, especially in a way of comparison. So we're going to talk about these three things, the concept of A440, the descriptors of acoustical energy, as I like to call them, and also just talking about the drum. Hi, come on in, please. So the whole concept of A440, like, why, right? Why A440? Or actually with most orchestras these days it's A442 and 443. But the reason is why. Why was that chosen? And there are two periods that we can talk about when it comes to pitch recognition and the establishment of some sort of standardization. Pre-1859 and post-1859. And what happened in the period before was simply travel was difficult. A was not the same A the next town over or the next church over. If you think, and this is pre-box, so more like Buxtehude time, Pachelbel-ish, so really early Baroque period, and medieval times as well. Some of the German organs were set to A567, which is actually a D, right? I mean, above A, and some were as low as 377, which is crazy. Handel had his own, his own A, and Mozart had his own A. But the Baroque opera was kind of the start of reining in this idea of standardization of A. Because, again, German organs, no one is singing along with that. It's just way too far out of any vocal range or any stringed instrument, right? If you're thinking catgut, there's no way you can wind an instrument up that much without it breaking. 1859 is when the French decided we're done with this, we need to have a standardization. Okay, they established in 1859 that A will be 435 hertz. After that, the reason things began to creep higher and higher is the larger concert halls, right? Outdoor venues. It's like there's people want to hear brighter things in order, especially I'm a horn player, for me to be heard, especially because I'm playing the wrong way, we have to play brighter. We have to get to the back of the hall, which is a very Chicago Symphony, Boston Symphony type of sound quality. And of course, the people in Britain were like, no, we don't want to be the same as the French. No, so they established 439, which if you're a math nerd, is that it's a prime number. You cannot divide that number. So in 1939, the international standard was decided to make A440 the standard. The reason is that there's a certain type of crystal that resonates when you add energy to it, and you insert math here, and it becomes divisible. You're able to define this number. So that's when, 1939, that's when the BBC would broadcast an A, just a drone, over radio signals. But the question is, but how, right? The establishment of it. John Shore, one of Handel's trumpet players, invented the tuning fork in 1711. And when he cast that tuning fork, that was the beginning of Handel's standardization of pitch. But even Handel's tuning fork was a little bit lower than that, right? It was 421.3 or whatever it said earlier. Today we think of Baroque pitch at 415, nicely low. Classical pitch set was a bit higher at 425, and today's opposite at 440. In 1834, the concept of hertz, right, the cycles per second. Before then, they weren't talking that. They were just like We want this sound quality for our A, for our establishment. But in 1834, a couple of German dudes came up with this mechanical stroboscopic device where they were actually able to measure cycles per second, how many, just the resonance over time. And like I mentioned before, this creeping up of pitch, and even today, if you talk to folks in the Metropolitan Opera, they're becoming a little bit furious because New York, they're going higher and higher. They're already at 443 as an established pitch, and they're creeping up to 444, believe it or not. But it still doesn't answer the question of who says? Why? Like why? Why is it? Why did all these people come around to this idea of a 420 through 440? Like, why did that hurt? And honestly, it's just because it felt right. And through all the research, there was no definitive, it's because of this one action. It was because it felt right, right? Especially in that time, in small chamber room settings, you didn't have to play as bright, you didn't have to play as loud. But today, the modern trombone, it's really hard to keep up with that instrument in an orchestral setting. They're very, very loud, so brightness from all the other sections have to come forward to keep up, right? Oops, wrong way. Oh, right way. Moving on, the idea of acoustical energy. There are, and this is what I teach a lot with my students, and I hope this makes some sense to you. There are 4 descriptors of acoustical energy that I try to convey to my students as much as possible. And the first one is a waveform, right? We all know this, that our instruments sound the way they do because of a resultant waveform, right? And for instance, here are the first 3 harmonics of a particular sound. You have the fundamental in red, the second harmonic in purple, the third one in blue. Those things, when you add them all together, come up with green, right? The timbre of your instrument. And this is what I try to get across with my students. You sound like a horn because you play a horn, but you also have your individual sound. What are you doing to create your sound concept? And the base idea is through the waveform. The second descriptor of acoustical energy, frequency, right? What we associate with pitch. And again, when I was younger, I didn't understand that I was able to move my pitch. I thought when I put 1 and 2 down, that was an A. There's no reason for me to move, right? Because I couldn't hear it because I started so late. The third one is obviously amplitude, right? Angry birds, right? Loudness. If you're a clarinet player, you play loud, you're going to go flat. If you're a brass player like me, you play loud, you're going to go sharp. Knowing the tendencies of your instrument is critical to any sort of discussion when it comes to intonation within your instrument group, not only in an ensemble of different instruments, right? This is my favorite one, right? The sound envelope, the ADSR, attack, decay, sustain, and release. My students, I don't know how they do it. They're really good at it. They are able to portray 4 different pitches in 1 note, right? and I don't know how they do it. It's really amazing. And it actually happens in this way, right? When they hit the note, they're incredibly sharp. And then they bring it down to where, into the decay, where it's kind of in tune, and they sustain it, and they start going flat because they don't realize they're using the air right. And then when they release it really flat. And it's this kind of training that I missed, that I didn't have. You're all musicians. It's a fairly simple understanding, but it was very, very difficult for me to wrap my head around the fact that just the concept of not only attacking the note in tune, but releasing the note in tune is absolutely critical. And now that I'm also a band director, it's like, then you got to get the ensemble to do it, to release together, to attack together. That challenge that you have to get through. I love this quote. It's really great. Christopher Luba was the former principal horn of the Chicago Symphony, and he was a rough guy, but a very good educator and very precise, right? It's just not enough is done about, there's not enough discussion about pitch. And again, I'm hearkening back to when I was a student and the things I've learned over time, especially through my doctorate. This is where I really kind of dug into this stuff. Okay, the drum. This is where my technology would have been really cool if it were to stay here. So I'm going to use my little computer here to show you guys the tonal energy app. Are all of you aware of that specific application, yay or nay? I'll talk about it as if you may not be. So I appreciate a little patience. But I just want to show you some different things on the app that may be new to you. I'm going to attack this syntax is not the nicest word, but this is what I do with my students, is to grasp the concept of intonation through intervallic training. Okay, knowing your intervals, just the concept of just intonation. Now, we could spend hours talking about just intonation, pure temperament versus equal temperament. But for now, we're going to talk about just intonation, which requires that you have to adjust your intervals to the physical surrounding of your instrument, the temperature of the room, and whom you're playing with, or with whom you are playing. The second thing is a chart that I will show you in the next slide, and obviously comparing to other. These are the three things that I just slammed into my students. It's like, know these things, and they get this chart. Oops, hold on. This chart. With all the intonation tendencies that are out there. Before, when we talked about the early 16th century organ, medieval organs, it was around here that some of them were tuned, right? C sharp and D. Right? They're just outrageously high, and some were outrageously low, like, oh, I don't have it on here. But it was actually kind of similar to D sharp, below 377-ish. So this is the simple chart I give my students. Actually, it's not simple. It's kind of complicated. But it's this particular column that I actually test my students on this. I literally make them write it down. Like, where are you supposed to put the tritone? Where are you supposed to put the major sixth? For some odd reason, in this part of the country, horn players cannot play a major sixth in tune. But if I go to the Midwest and do lectures, and they're like, pow, it's right in tune. I think it may have a lot to do with our early upbringing, and a lot of students that I see are very late into the music scene, especially when it comes to learning how to listen. But you got to drag that bad boy down really far to get it in tune. Let me go back one here. The Tonal Energy app. This is just a fantastic application. I mean, it doesn't necessarily replace the Peterson Strobe Tuner, but the Peterson Strobe Tuner is $1,000. This app is $4, right? It's a fantastic application. Now, the arrows where things are pointing are kind of the crux behind this. So what we're playing here is a B flat, right? A B flat is being played. Or sorry, we're in just temperament of B flat. And what's being played is the big guy there is the D, okay? And there's two settings here. If I were to play a D over here, where it's red and really sharp at A440, it would register as super sharp within the key of D, right? It's the third. You obviously know that, sorry. But what's required, the type of energy from the student is required. They're required to drag it down in order to get the super smiley face, okay? Where it will register as in tune, but you'll notice this little guy here, the orange arrow up here and down here, will show you how much you have to adjust, okay? Because up here, the D is registering as 0 at the orange arrow. That means you are perfectly in tune at A440 at equal temperament, okay? And I'm just showing you the differences of how it looks when you're A440 and then when you have to tune to just temperament within the key itself, right? You have to drag it down 13.7 cents to get it in tune. That's just kind of the crux of tonal energy. And what I wanted to show you up here, because it would make more sense, but I'll do it here, is to sustain a C major chord. Hopefully it's not too loud. I'll turn it down. There we go. Sorry, I usually start with the perfect fifth. Even with the perfect fifth, it's just really disgusting when you add the third. It's just a disaster, right? Like, it's a real mess. And this is what I like to show my students. It's purely in tune, right? Just a different quality of sound. That's right. I just go back and forth with a lot of different intervals. My favorite one is the major sixth, right? Sorry, guys. although I do work in a more of a rural setting at the University of Idaho, the students that I see and that I recruit, or the students that show up to my institution, they just don't have this kind of training, in which I am very empathetic to that, because that's a very similar background that I had. I didn't have this until, actually when I started my doctorate, this kind of technology, because it just wasn't developed yet. But I was doing the droning thing during my undergrad for sure. So that's kind of the idea with the beginning of intonation, the beginning of pitch, and the reasoning behind the use of a drone. Now, I've developed actually a bunch of exercises that I have my students do, and they work really, really well. One is just very simple long tones, working on the simplicity of, trying to make it as simple as possible, just working on the unison. I'll just simply play the first note for you. What key are we in? Okay, the G. So I don't even put it on just temperament. This is just equal temperament, just working with a basic drone. And I'll throw it on what is a horn G. I play a transposing instrument. It is horribly annoying. But what I want to show you, if you can see this thing, is the ability to really kind of move your pitch around. Right, you see this great visual representation of what's going on with the pitch, right? And I love that. Like, if you're really out of tune, the dude is like, about tonal energy is that it's constantly working through a logarithmic equation. It's really, really fast, but it's nearly impossible to get it to sit there at 0.0 in tune, because it's constantly cycling through the equation of what it's hearing, and it's constantly updating it, whereas an analog tuner has no problem displaying, boom, you're perfectly in tune or you're slightly out of tune, right? Because it's constantly working through this mathematical logarithmic equation to analyze your pitch, whereas an analyze your pitch, whereas an analog tuner does not have to do that. Next one, the introduction of the perfect fifth. I like this one a lot because it forces my students to play lower. Most brass students play very, very high, but this forces my students to play lower. So I just established this actually at the same pitch. I'm going to play a G, but this time it's going to be just intonation with the key of G. I do it 2 octaves. So. And you're more than welcome to do the rhythm, but here, so you can see it. Oh wow, that's not what I wanted. This one, and especially the next one, I don't know if you guys have had a chance to work with the waveform portion of this application of tonal energy with my 2 minutes that I have left. This one I like a lot because, again, it tunes the major 6. You can tune whatever you want. I just make my students this one because the major 6, because they have no concept of playing it in tune, and also it requires you to play really, 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 really loud. And with the analysis portion, again, I won't gross you out with my really, really loud sound. but I really wish this was bigger. I apologize again for the technology issue, but with the analysis portion of this app, there's this fun little orange line on here. Where you can follow the line, and if my attacks, you see that coming flat, it came in sharp, things like that. They can really show your students what in the world is going on. And then if I play loud, I'll play it like a typical student. Sorry, maybe I should play it too. Like when my students get loud, they can literally visually see, they can visually see what's happening, right? It's just because of, maybe it's because of the technology that our students have access to. Thank you. And the idea that, well, let's cater to that. There's no way around it. They're going to have a phone. They're going to have this visual aspect in their learning. Okay, cater to that. This is on their phone. Tonal energy is on any phone, any device. It's just a really, really phenomenal application. The last thing I did want to show you is the waveform part of the app, and also the actually not necessarily the waveform, but I wanted to show you the spectrometer. The spectrometer of the application shows you, it's not on here, you've seen enough. The spectral analysis of this application shows what harmonics are sounding when and how. For a horn player, it's an indication if you have some. That's supposed to be silent, sorry guys. It has an indication as to whether or not there's a dent in your horn. If there's damage to your instrument, part of your harmonic will not sound right. It will actually register lower. It's one of those things I wish technology worked, but you can see the little spikies resonate, and it just shows you which harmonics are sounding. And if you want a better representation, you get the bars. It shows you what harmonics are sounding from the note that you're playing, not necessarily the root, but the note that you're playing. I have a great appreciation for this application. I wrote a zillion different exercises. This is just a 3-octave unison, working on literally creating the sound envelope. Unfortunately, my microphone is really, really sensitive. I'll give it a whirl. This microphone's too sensitive. Bit far away. Right, you can see the ends of notes, and you can teach your students how to shape a note, not only by the shape. Where's the orange line? I'm playing sharp today. Make sense? Right, it's a really easy way to visually show your students, which is what I needed. If you have younger students who have been around instruments since, third grade, thank you, then they're going to be in a lot better shape. The last thing you need to do is sing, okay? I'm out of time, but if you need any more information, join with a purpose. It's all about how it sounds. It's all about, just kind of went back from how they made tuning forks. It's how it sounds, does it feel right? If it doesn't, do something else. If it's good, keep going and spend a lot more time singing. If you have any question for me, great, but we do need to set up for the next presenter. But any questions at all? Anything I can answer? Yes?
So in your chart, comparing equal temperament to just temperament, I was curious about the minor seventh.
Okay.
Because the dominant seventh chord derives from the harmonic series.
Yes.
And you said just 4 cents flat there, but in the harmonic series, it's the minor seventh is really
Depends
flat.
on which harmonic series. Yes, because if it's within the 9th partial of my instrument, it is obscenely flat.
Yeah.
But if you're thinking just the physical nature of how these things resonate with each other, it's actually only 4 cents flat. Just when you're talking the hertz compared to A440. You're right, but on my instrument, it is flat. But that's my instrument.
Okay.
Yeah. But I mean, you bring up a very good point. It's like, how do you compare that and things like that? Yeah.
Yeah, so then with that, does the minor seventh change then when you add the third and the fifth in? Because it seems like I've seen a couple of other charts before where the minor seventh is part of the dominant seventh chord is supposed to be like 30 cents flat or something like
Right.
that.
No, well.
Or that chart is just wrong.
No, and I mean, and you bring up a good point, and I did a bunch of tests with different analog devices and different digital devices, because you're right. This is the third of the 5 chord, right?
Yeah.
Or the leading tone. Or no, sorry.
It's the seventh.
Sorry,
five
this
chord.
guy. Sorry, yeah, sorry. And yeah, it's got to be low. It has to be low, but you're right. Some of them like trying
Well, we
to
can
30
continue
cents.
talking
Sorry,
about
we
that.
have
But
Yeah, no,
good.
no.
But no, you asked
Sorry.
very good questions, and this is specifically just for A440 itself.
Yeah.
No, because it is my personal opinion that other keys act differently, especially
Right.
D flat. Oh, those notes are
Right.
crazy. Yeah, crazy different. Thank you, everybody. Appreciate it. Thank you for saving the day.